In this video, we're going to look at an infinite series known as a harmonic series, and we're going to prove that the harmonic series diverges. So the question here is to show that the harmonic series summation n goes from 1 to infinity 1 over n diverges. Let's expand out the summation 1 over n, so we get summation 1 over n is equal to 1 plus 1 half, putting in n equals 2, 1 over 3 plus 1 over 4, and in general 1 over n for the nth term, plus dot dot dot. This goes on forever. Let's consider a sequence of partial sums according to the powers of 2 to the n. So S1 is really S2 to the 0, S2 is S2 to the 1, S4 is S2 squared, S8 is S2 cubed, S16 is S2 to the power of 4, and S32 is S2 to the power of 5. So let's start with S1. S1 is the first term, that's just 1. S2 is the sum of the first two terms, that's 1 plus 1 half. So 1 plus 1 over 2, and this gives us 3 over 2. S4 is the sum of the first four terms, that gives us 1 plus 1 half, plus 1/3, plus 1/4. So S4 is equal to 1 plus 1 half plus, now let's group 1/3 plus 1/4 together, and we're now going to form an inequality. This is larger than 1 plus 1 half plus, I'm going to put something here to make the right hand side less than the left hand side. So plus 1/4, what should we put inside this box? We're going to put 1 over 4. Because you're putting something smaller on the right hand side, so the right hand side is less than the left hand side. If we add all of this up, we get 1 plus 1 half plus 1/4 plus 1/4 is 2 over 4. That's 1 half again. And we get 1 plus 2 over 2. We're not going to simplify this because we want a pattern to develop. Now let's look at S8. So S8 is equal to 1 plus 1 half is the sum of the first 8 terms, plus 1/3 plus 1/4 plus 1 over 5 plus 1 over 6 plus 1 over 7 plus 1 over 8. Now we need to form an inequality. S8 is going to be larger than 1 plus 1 half plus, we're going to put 1/4 because 1/4 is less than 1/3. So 1/4 plus 1/4. Now let's put in 1/8. 1/8 is less than 1 over 5. Replace 1 over 6 also by 1 over 8. Replace 1 over 7 by 1 over 8. And the last term, 1 over 8. So we get S8 is larger than 1 plus 1 half. 1/4 plus 1/4 gives us 2 over 4, that's just 1 half. And 1/8 plus 1/8 plus 1/8 plus 1/8 gives us 4 over 8, which is 1 half again. So we get 1 plus 3 over 2. Now, if we apply the same maneuver, we can show that S16 will be larger than 1 plus 4 over 2. And similarly, S32 is larger than 1 plus 5 over 2. And this is the pattern that we were looking for. So let's look at the pattern. We have S8 is larger than 1 plus 3 over 2. Now that means that let's rewrite 8 as 2 cubed, is larger than 1 plus 3 over 2. Let's look at S16. S16 we proved is larger than 1 plus 4 over 2, the sum of the first 16 terms of this harmonic series. So we get S2 to the 4 is larger than 1 plus 4 over 2. And this is how we develop the pattern, because you can see that we have a 4 here and a 4 here. We can replace that by n. Here you have 3 and 3 here. That's how we develop the pattern. So now we can see that the general pattern is going to be s 2 to the n is larger than 1 plus n over 2. Now let's take the limit of both sides. So the limit as n goes to infinity of s 2 to the n is larger than the limit as n goes to infinity of the right-hand side, which is 1 plus n over 2, and the right-hand side, of course, approaches infinity because n over 2 approaches infinity as n goes to infinity. Now, we have proven that the partial sum s2 to the power of n approaches infinity as n goes to infinity. Therefore, we can see that the limit as n approaches infinity of the nth partial sum is going to be infinity. And therefore, the harmonic series summation 1 over n goes from 1 to infinity, diverges to infinity. The harmonic series is an example of a divergent series whose terms an approach 0 as n goes to infinity, but the summation is infinite. The summation 1 over n goes from 1 to infinity, the infinite series diverges to infinity. All right. Now let's look at this example here. Evaluate the series n goes from 2 to infinity, 3 over n plus 1 over 3 to the n. We're going to start by splitting up this sum into the sum of two separate series and evaluate each sum separately. Now, let's look at the first case. So we have summation n goes from 2 to infinity, 3 over n. Let's split it up first, 3 over n plus 1 over 3 to the n. This is equal to summation n goes from 2 to infinity, 3 over n, plus n goes from 2 to infinity, we split up the sum, 1 over 3 to the n. Now, the first series, which is this one, is the harmonic series. The fact that it starts at 2 doesn't make a difference. You can start at any index. So we can just factor the 3 out and see that this is, in fact, the harmonic series that we proved converges. So this is harmonic series, and diverges. The sum diverges to infinity. Now, the second series, n equals 2 to infinity, 1 over 3 to the n, this is a geometric series. In fact, it is a convergent geometric series. The reason it's convergent is because r equals 1/3. The common ratio is less than 1. So this is a convergent geometric series. Because r equals 1/3 is less than 1. However, the entire series, summation n goes from 2 to infinity, 3 over n, plus 1 over 3 to the n, this entire series diverges. The reason is because summation 3 over n equals 2 to infinity, is a divergent harmonic series. And if one of the series diverges, the whole sum diverges. Divergent harmonic series. So key concept, for the entire series, summation n goes from 1 to infinity, an plus bn, to be convergent, both summation n goes from 1 to infinity an and summation n goes from 1 to infinity bn have to be convergent. And if one of these series, say summation an, diverges, then the entire series, summation an plus bn, also diverges. In this case, the part of the entire series that diverged was this part, 3 over n. Summation 3 over n is a divergent harmonic series, and that caused the entire series to diverge. Even though 1 over 3 to the n is a convergent geometric series, the whole sum diverges because of the fact that 3 over n, summation 3 over n, is a divergent harmonic series. It's a divergent series. All right, thanks.